Welcome to another video by Team Matcom. In this particular video, we will be doing with how to calculate the formal charge in each species in a molecule. This is comes under the chapter 4 in class +1 chemistry, that is chemical bonding. So we will see what do you mean by formal charge and how we can calculate the formal charge. All those things we will see in this particular video. We will take one particular example. For example, if you consider a molecule called a carbonate ion. Carbonate ion mean CO3 2 minus. CO3 2 minus. First, you need to find out how many electrons are involved in this particular molecule. Only we will be considering only the valence electron. When you consider carbon with atomic number 6, electronic configuration is 1s2, 2s2, 2p2. That means 2 is the valence shell. There are 4 electrons in the valence shell. When you consider oxygen atomic number is 8. If you write the configuration 1s2, 2s2, 2p4, there are 6 electrons in the valence shell. 6 electrons in the valence shell. According to octet rule, we know that the more atoms will undergo bonding in order to have 8 electrons in the valence shell. That means in order to complete the octet. That means in order to have 8 electrons in the valence shell. For example, when you are considering carbon is having 4 electrons. It requires 4 more electrons in order to complete the octet. When you consider oxygen is already having 6 electrons in the valence shell. It requires 2 more electrons in order to complete the octet. When we consider carbonate ion, there is 1 carbon. That means 4 electrons. We have 3 oxygen. 1 oxygen is 6 electron. That means 3 oxygen will be 3 into 6. That is equal to 18 electron. We have 2 negative charges. 1 negative means 1 electron. 2 negative means 2 more electron. If you take addition, it will come 18 plus 4, 22. 22 plus 2 is 24 electron. In this particular molecule, there is an involvement of 24 electron. Now we need to draw the structure. When we are drawing the structure, we need to put the least electronegative atom as the central atom. Here when you consider carbon and oxygen is more electronegative than carbon. So carbon will be placed at the central atom generally. Then we have 4 electron around it. 1, 2, 3, 4. 4 electron around it. We have 3 more oxygen around it. When you consider oxygen will be having 6 electrons in the valence shell. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That means 6 electrons in the valence shell. So one of the oxygen atom can form a double bond with the carbon. Double bond with the carbon. If it is forming a double bond, this oxygen is getting 2 plus 2, 4. 4 plus 2, 8. The octet of this oxygen is completed. No issue in that. When you consider the carbon now, carbon can have 2 more electrons. It can form only 2 more bonds because already there are 4 electrons in the valence shell of the carbon. So carbon can take only two more electrons. That means carbon will form a single bond with this oxygen. Carbon will form a single bond with this oxygen also. When you consider the octet of this particular carbon is completed. But when you see, we can see that in the system we have a 24 electron. We have introduced only 22 electron, correct? Why? Because for example, in each oxygen we have introduced 6 electron. Each carbon we have one carbon is already there. We introduce 4 electron. Total we have 22 electron. We have 2 electron as a result of 2 negative charges. That means when you consider this oxygen, there is 2 plus 2 4, 4 plus 1 5, 5 plus 2 7. 2 plus 2 4, 4 plus 1 5, 5 plus 2 7. These 2 oxygen are 1 electron less in order to complete the octet. That means we can have 1 more electron on the each oxygen. Done. Now we need to find out the formal charge. Before finding out the formal charge, we need to know the equation. Also, we can just number it. We are just numbering this carbon as 1, this oxygen as 2, this oxygen as 3, this oxygen as 4. You can number it in any way. How to calculate the formal charge? The formal charge can be calculated. Formal charge is equal to number of valence electron in the neutral atom or in the neutral state, number of valence electron in the neutral state, minus 1 by 2 into number of bonding electron, minus number of lone pair of electron, number of lone pair of electron. That means you can write it as valence electron minus 1 by 2 into B minus L. Okay, that means V minus L by L minus B by 2. You can write it. This is the way in which you can calculate the formal charge. Okay, fine. Now, if you take each species, first case, the formal charge on the first species, Fc1, let it be carbon. How many electrons are valence electrons are there? 4 valence electrons are there, minus. Is there any lone pair? There is no lone pair, that is equal to 0. Minus 1 by 2 into how many bonded electron? 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. Into 8. 2 and 8 cancel, you will get 4. 4 minus 4 equal to 0. Therefore, formal charge of the carbon in this particular molecule is 0. Next, the formal charge on the first oxygen, let it be this one, numbered as 2. Number of lone pair, number of valence electron is 6 minus number of lone pair of electrons is 4 minus 1 by 2 into number of bonded electron pairs is 4. 4 divided by 2, you will be getting 2. So 6 minus 4 minus 2, that is 6 minus 6, that is equal to 0. Correct? Done. Next one, formal charge on the third species, Fc3. Number of valence electron, that is 6, minus number of lone pair of electron, that is minus 6, minus 1 by 2 into number of bonded electron pairs, that is 2. 2 by 2, that is 1. 6 minus 6, 0, minus 1. So the formal charge on this oxygen become minus 1. When you consider this oxygen, this is also in the same state, but we can just calculate Fc4 equal to number of valence electron is 6 minus number of lone pair of electron is 6 minus 1 by 2 into 2. 6 and 6 cancel. 1 by 2 by 2, you will get minus 1. So 1, that is nothing but minus 1. So formal charge is minus 1. So formal charge on the first carbon and the second oxygen is 0. This oxygen is minus 1. This oxygen is minus 1. This is the way in which you need to identify the formal charge. We will take one more example, that is called O3. Nothing but called ozone molecule. Nothing but called ozone molecule. O3 means there are 3 oxygen. When you consider one oxygen, there are 6 valence electron. So total this molecule have 18 electron. We are representing 3 oxygen molecule. Each oxygen is having 6 valence electrons. 6 valence electron. So each oxygen requires 2 more electrons in order to complete the octet. So there can be one double bond can be established between these two. So octet of this oxygen is complete. Octet of this oxygen is complete. But bonding is not completed. So what is the possibility? There can be a single bond can be established between these two oxygen. So now this electron is having 8 electron. This is having 3 plus 1, 5, 2 plus 1, 3, 3 plus 6, 9 electron. Here if you take 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7. That means this this particular oxygen atom, the octet is complete. For this particular oxygen atom, there is 1 electron extra. For this particular oxygen atom, there is 1 electron less. That is why there is an electron exchange can happen, or electron rearrangement can be done such that 1 electron from this oxygen atom will be transferred to this oxygen. As a result, one electron will be transferred to this oxygen. So this is getting 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. Here already 6, 6 plus 2, 8. Everything octet is complete. Now we will find out the like a formal charge. Let it be first, second, third. So the formal charge of the first atom, that is equal to number of valence electron, that is 6, minus number of lone pair of electron, that is 4. Number of bonded pair of electron, that is equal to 1 by 2 into 4. That is 6 minus 4. 1 by 2 into 4 is 2. 6 minus 6, that is equal to 0. So the formal charge of the first oxygen atom is 0. If you consider second oxygen atom, that is Fc2, that is number of valence electron is 6, minus number of lone pair of electrons is 2, minus 1 by 2 into number of bonded pair of electron, that is 6. 6 by 2, that is equal to 3. That is 6 minus 2 minus 3, that is 6 minus 5, that is equal to plus 1. So the formal charge of the second oxygen atom is plus 1. Now the formal charge on the third atom, number of valence electron, that is 6, minus number of lone pair of atoms electron, that is 6, minus number of bonded pair of electron, that is 1 by 2 into 2, 2 and 2 will get cancelled. You will get 1 here. 6 minus 6, 0. 0 minus 1. So the formal charge on the third atom is going to be minus 1. So what would be the structure? Structure can become O, O. This have a lone pair of electron. It is having 2 lone pairs of electron. It is having 3 lone pair of electron and a negative charge. It is having a positive charge. This is the way in which we can draw the structure of ozone molecule. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.